Alright, today we're going to be talking about Chapter 5, Lesson 7. It's called The Distance on the Coordinate Plane. So, Pythagorean theorem with Lesson 6, we can use that to find distance on a coordinate plane. Because really, if you think about it, if we graph a line, we can create a triangle off of that. So let's go ahead and start looking at this. Example 1, it says graph the ordered pairs 0, negative 6. So that's here, down 1, 2, 3, 4, 5, 6. So this is 0, negative 6. And then 5, negative 1 would go to the right 1, 2, 3, 4, 5. Down 1, and that's right here. If we can connect those two dots with a line, we can make a triangle, because this would represent the hypotenuse then. So here's our hypotenuse of the triangle. And if we did this, now you could also draw a line going up and across like this, but I like doing it this way. This creates a right triangle. And if we look here, going along the side, each line is worth 1, so we go 1, 2, 3, 4, 5. So that side is worth 5. And 1, 2, 3, 4, 5 again, that side is also worth 5. So we've created a triangle, and the distance is going to be the hypotenuse here. So if I utilize those two numbers, 5 and 5, so 5 would go in for A, 5 would also go in for B, and then C squared is something that I don't know yet. So 5 squared is 25. Another plus 25 equals C squared. Combine those two terms, I get 50 equals C squared. Take the square root of both sides. And then if we look at this, the square root of 50 is 7.07 and a few other numbers. But because it says to round to the nearest tenth, the distance is 7.1 units. The reason why we have to put units on there is because we're measuring a distance between two things. Now, there's also something that we can use. It's called the distance formula. So the distance formula is going to look a lot like Pythagorean theorem. If we look at our diagram here, we have a triangle where this side and this side are A and B. If we have these two ordered pairs, x1 and x2, the distance from here to here is x2 minus x1. Just like if we were doing slope. The distance going up and down then would be y2 minus y1. And if you remember, our slope formula was y2 minus y1, which happens to be the rise, divided by x2 minus x1, which happens to be the run. So essentially what we're doing is we're using our slope information to help us find this total distance. So if we utilize x2 minus x1 as A, then we have x2 minus x1 squared. Same thing here with B, we have y2 minus y1 squared. That equals C squared. But in this case, C, we're going to represent by the letter D for distance. So now we have the distance on one side, squared, plus the distance on the other side, squared, is equal to the total distance between two ordered pairs. Now to find the distance, we have to take the square root of that, and that is where we get the distance formula. So square root of x2 minus x1 squared plus y2 minus y1 squared equals D, and that's the distance formula. So let's do some examples here. Example 2, it says Reed lives in Seattle. 1 unit on this map, so this is the map here, is 0.08 miles. Find the approximate distance that he drives between Broad Street at Denny Way, which is going to be right here, and Broad Street at Dexter Avenue, which is right here. So we're finding this distance along this road that he travels. This here is our y-axis, this is our x-axis, so this ordered pair here is -1, 0, as it states right there. And this ordered pair would be 4, 5, again, as it states right there. So one of two ways that you can do this. If you have a graph, you can find out this distance and this distance. But if you don't have that graph, if you just have the ordered pairs, we can use the distance formula. I'm going to call this ordered pair 1 and ordered pair 2, just like if we were using our slope information. So the distance formula talks about how the difference between the x value from the second ordered pair and the x value of the first ordered pair. So I'm going to start substituting my numbers in. x2, the x from the second ordered pair was 4. X from the first order pair is -1. Now I have the y terms. So the y value from the second order pair is 5. The y value from the second order pair is 0. If I start solving this now, remember, order of operations comes with parentheses first. So 4 minus a -1 is 5. And 5 minus 0 is also 5. Exponents comes next. So now I have 25 plus 25. I'm then going to add those two numbers together to get the square root of 50. And we did that on the previous side. So D is about 7.1 units. Now in the problem it says 1 unit on this map is 0.08 miles. So now what we're going to do is we're going to take this 7.1 units and multiply it by 0.08. Because it's 0.08 per mile, or per unit, and we're looking at 7.1 units. So if I do this multiplication, I get that Reed, so this is going to be equal to 0.568. Probably going to want to round that, so, but Reed drives about 0.6, 0.57, something like that, miles on that road. And then last example, example 3. So in this one, you could have used Pythagorean theorem to find this distance is 5 and this distance is 5. You could have done that. But now in example 3, we don't have that luxury of having a graph. It says use the distance formula to find the difference between G and H, round to the nearest tenth if necessary. So I'm going to write down my distance formula. I'm going to label this ordered pair as 1 and this ordered pair as 2. So the x value from the second ordered pair is -6. The x value from the first ordered pair is -3. Y value from the second ordered pair would be 5. from the second ordered pair is negative 2. Parentheses first, negative 6 minus a negative 3 is negative 3. 5 minus a negative 2 is 7. Exponents next. Negative 3 squared is, be careful, it's 9. And 7 squared is 49. Combine 9 and 49 together, we get 58. And then the square root of 58 rounded to the nearest tenth. So right now I have d equals 7.615. Rounded to the nearest tenth, the distance would be 7.6 units. Alright, that is the end of lesson 7. If you have any questions, please let me know.